Before we begin, be sure to like this video and subscribe to the channel for more cosmic adventures. The sun, a giant ball of burning gas. It dominates our sky, it gives us life. But have you ever wondered where the sun came from? How long will it shine? What will happen when it dies? The sun's story is an epic tale of birth, life, and death. It's a story repeated across the universe. And today, we're going on a journey to unravel the mysteries of our very own star. Imagine a vast, dark cloud of gas and dust. This is not just any ordinary cloud, but a colossal, sprawling expanse that stretches across light years. It's a place where the magic of the universe begins, a nursery for the stars. These clouds, known as nebulae, are the cradles of creation, where the building blocks of stars are gathered. This is a nebula, the birthplace of stars. Within these colorful and vibrant regions, the raw materials for star formation are abundant. Hydrogen, the most common element in the universe, along with helium and traces of heavier elements, all come together in a cosmic dance. Billions of years ago, our sun was just a tiny part of one such nebula. It was a time when the universe was still young and the Milky Way galaxy was bustling with the activity of star formation. Our sun, like many other stars, began its journey in one of these stellar nurseries. Over time, gravity started to pull the gas and dust together. This force, which governs the motion of planets and the formation of galaxies, began to work its magic on the nebula. Slowly but surely, the particles of gas and dust started to clump together, drawn by their mutual gravitational attraction. The cloud collapsed in on itself, getting smaller and denser. As the material gathered, the pressure and temperature within the cloud began to rise. The once diffuse and cold nebula started to transform into a hot and dense region, setting the stage for the birth of a star. As it shrank, it started to spin faster and faster, like a spinning figure skater pulling in their arms. This conservation of angular momentum caused the cloud to rotate more rapidly, creating a flattened, spinning disk of material. At the center of this disk, the protostar, the early stage of a star, began to form. This spinning motion generated heat. The friction and compression of the gas particles caused the temperature to rise dramatically. The core of the protostar became incredibly hot, glowing brightly as it continued to accumulate more mass from the surrounding disk. Temperatures at the center of the collapsing cloud soared, millions of degrees. Then, something amazing happened. The conditions became just right for nuclear fusion to ignite. This process, where hydrogen atoms fuse to form helium, releases an enormous amount of energy. The intense heat and pressure triggered nuclear fusion, the process that makes stars shine. Our sun was born. This nuclear furnace would continue to burn for billions of years, providing the light and heat necessary for life on Earth. From a simple cloud of gas and dust, a star was born, and with it, the potential for planets, life, and the wonders of the cosmos. Nuclear fusion is the powerhouse of stars. Imagine tiny atoms smashing together at incredible speeds. That's what happens in the sun's core. Hydrogen atoms, the simplest and most abundant element in the universe, collide with such force that they fuse together, forming helium. This fusion process releases a tremendous amount of energy, the energy that lights up our solar system. The sun is currently in its main sequence phase, happily fusing hydrogen into helium. This phase lasts for billions of years. It's like the sun's adulthood, a long, stable period where it shines brightly and steadily. During this phase, the outward pressure from nuclear fusion balances the inward pull of gravity. This balance is what keeps the sun from collapsing under its own weight. It's a delicate dance, but one that the sun has mastered for billions of years. Section 5, the red giant phase, expansion and change. But the sun won't stay on the main sequence forever. The main sequence is the phase in a star's life where it spends the majority of its time burning hydrogen into helium in its core. This process releases a tremendous amount of energy, which is what makes the sun shine so brightly and provides the heat and light necessary for life on Earth. Like a car running out of fuel, the sun will eventually exhaust the hydrogen in its core. Just as a car needs gasoline to keep running, the sun needs hydrogen to continue its nuclear fusion process. When the hydrogen runs out, the sun will no longer be able to sustain the fusion reactions that have powered it for billions of years. When this happens, in about 5 billion years, the sun will enter a new phase, the red giant phase. During this phase, the sun will undergo dramatic changes. It will expand to many times its current size, engulfing the inner planets, including Mercury and Venus, and possibly even Earth. The transformation into a red giant is a natural part of a star's life cycle, marking the end of its stable period and the beginning of its decline. Without hydrogen to fuse, the sun's core will start to contract. This contraction is due to the gravitational forces pulling the core inward. As the core contracts, it becomes denser and hotter. The increased pressure and temperature in the core will cause the remaining hydrogen in the surrounding layers to start fusing. This contraction will heat up the core even further, igniting hydrogen fusion in the layers surrounding the core. The fusion of hydrogen in these outer layers will release a significant amount of energy, causing the outer layers of the sun to expand. This process is similar to how a controlled fire can spread and grow, consuming more fuel and releasing more energy. This extra energy will cause the sun's outer layers to expand outwards, turning it into a red giant. The expansion will be so vast that the sun's diameter could increase up to 100 times its current size. The outer layers will cool and take on a reddish hue, giving the red giant its characteristic color. This phase will last for a few 100 million years before the sun sheds its outer layers and leaves behind a dense core known as a white dwarf. Section 6. The fate of the sun's core. As the sun expands, it will engulf the inner planets, including Mercury and Venus. Earth's fate is uncertain. It might be swallowed by the expanding sun, or it might be pushed out into a wider orbit. Either way, life as we know it will be impossible on our planet. Meanwhile, deep inside the sun, the core will continue to contract and heat up. Eventually, the core will reach temperatures high enough to ignite helium fusion. Helium atoms will fuse together, forming heavier elements like carbon and oxygen. Section 7. Planetary nebula, a cosmic work of art. The helium fusion phase is much shorter than the hydrogen fusion phase. After a few 100 million years, the sun will exhaust its helium fuel. When this happens, the sun's outer layers will be expelled into space, creating a beautiful glowing cloud of gas and dust called a planetary nebula. Planetary nebulae are some of the most stunning objects in the night sky. They come in a variety of shapes and colors, resembling giant jellyfish, butterflies, and other cosmic creatures. Section 8. White dwarf, the sun's final bow. At the center of the planetary nebula, the sun's core will remain. This core, now a super-dense object called a white dwarf, will slowly cool down over billions of years. A white dwarf is incredibly dense. Imagine packing the entire mass of the sun into an object the size of Earth. That's how dense a white dwarf is. Section 9. Conclusion. A legacy in the stars. The sun's journey from a nebula to a white dwarf is a story of transformation and rebirth. It began as a cloud of gas and dust, a nebula floating in the vast expanse of space. Over millions of years, gravity pulled these particles together, igniting nuclear fusion in its core and giving birth to our sun. This process of star formation is a common tale in the universe, yet each star's journey is unique. Although our sun will eventually die, the elements it forged in its core, carbon, oxygen, and others, will be scattered into space, providing the building blocks for future generations of stars and planets. As the sun ages, it will expand into a red giant, shedding its outer layers and enriching the interstellar medium with these essential elements. This cycle of death and rebirth is a fundamental aspect of the cosmos, ensuring that the materials needed for life are continuously recycled. The explosion of a supernova is one of the most spectacular events in the universe. When a massive star reaches the end of its life, it can no longer sustain nuclear fusion in its core, leading to a catastrophic collapse and subsequent explosion. This supernova scatters elements far and wide, seeding the cosmos with the ingredients for new stars, planets, and even life itself. Our sun, though not destined to become a supernova, will still contribute to this grand cosmic cycle. So, the next time you feel the warmth of the sun on your skin, remember the incredible journey it has taken and the legacy it will leave behind. From its humble beginnings as a nebula to its eventual transformation into a white dwarf, the sun's story is a testament to the dynamic and ever-changing nature of the universe. Every ray of sunlight is a reminder of the complex processes that sustain life on Earth and the interconnectedness of all things in the cosmos. It's a legacy that continues to shape the universe we live in. The elements forged in the hearts of stars are the very same that make up our bodies, our planet, and everything we see around us. As we gaze up at the night sky, we are looking at the history of the universe, written in the light of distant stars. This cosmic legacy is a reminder of our place in the universe and the ongoing story of creation and transformation that defines our existence.